Hi guys. In this video, we're going to be talking about oxidation reduction. Shorthand way, we're going to call it redox. Our SWBAT, analyze how to solve redox equations or how to balance them. That's what we're doing. Number 2, identify the oxidation half, which you all looked at that in the previous video. Number 3, identify the reduction half. And remember, we are going to be looking at oxidizing agent and reducing agent. In redox reactions, you balance the reaction according to charge and atoms. Okay? Oxidation. Oxidation is the loss of electrons. And when you have loss of electrons, you become more positive because you're losing the negative, so you become more positive. The oxidation half reaction contains the reducing agent. Let's take a look at reduction. Reduction is the gain of electrons. And when you're gaining electrons, you become more negative. So, and also this half reaction contains the oxidizing agent. So now, right now, we're going to take a look at the rules for solving a redox reaction or for balancing a redox reaction. So the first thing we're going to do, number 1, assign oxidation numbers. Number 2, after we assign the oxidation numbers, based on the change in the oxidation numbers, we're going to break it into half reactions. The oxidation half and the reduction half. Number 3, we're going to balance the atoms. Number 4, assign electrons lost or gained. Assign the number of electrons lost or gained. Number 5, if needed, add water to balance out the oxygens. If needed, add hydrogen to balance out the hydrogen ion. Add hydrogen ions to balance out the hydrogens. Number 7, make electrons the same by finding the least common multiple, LCM, least common multiple or least common factor. Turn the paper over. Number 8, cancel the electrons. Number 9, combine the half reactions. Number 10, make sure to check to see that the final reaction is balanced according to charge and atoms. Okay? So now guys, let's take a look at a reaction. And when we're doing this, I'm going to have the rules right here. We're going to be looking at the rules at the same time that we are going to be balancing this reaction. Okay? All right. Here we go. Now, this is an example. This is our first example we're going to do. I have cerium with a plus 4 charge, plus 10 with a plus 2 charge, yields cerium with a plus 3 charge, and 10 with a plus 4 charge. Now, the very first rule, guys, remember the first rule said assign oxidation numbers. For this particular one, we don't have to assign the oxidation numbers because if you take a look at it, each one of these already have a charge. So we don't have to do that. So we can do the number 2. Number 2 says break the half reaction, break into half reactions, the oxidation half and the reduction half. All right. So now let's take a look at this. I broke this down into cerium going from a plus 4 to cerium to a plus 3. I broke this down from 10 going from a plus 2 to 10 going to a plus 4. Okay? So I broke down into the half reactions. All right? So this is going from a plus 4 to a plus 3. This is getting more negative. So if it's getting more negative, that means it's gaining electrons. And we know that gaining electrons is what? That's right, reduction. So this part right here is my reduction half. And we know the reduction half contains the oxidizing agent. All right, so let's take a look at this bottom one. I'm going from a plus 2 to a plus 4. What am I doing there? I'm getting more positive. So this half is called the, that's right, the oxidation half. Okay? So now, let's do the next step. Balance the atoms. The atoms are already balanced. I got 1, 1, 1, 1. The next one, assign electrons lost or gained. That's number 4. So now, I'm going from a +4 to a +3. What am I doing with my electrons? That's right. I am going to have, you want to make both of these sides equal. You want to have, this is a +4, this is a +3. What can I do? How many electrons am I going to add or lose in order to make this equal in charge? All right? So now watch this. If I put 1 electron here, we know that electrons are negative. A -1 and a +4 make a +3. Okay? Let's take a look at the second one. This one right here. I'm going from a +2 to a +4. How many electrons am I going to be exchanged here? That's right, 2 electrons. But where are those 2 electrons going to go in order for this to be equal in charge? That's right, it's going to go on this side of the reaction, +2 electrons. So now, let's see if we're right. A -2 and a +4 gives you a +2. So that is correct. Okay? So let's take a look at our next rule. Our next rule is if needed, add hydrogen ions. We don't have to do that because I don't have to balance out hydrogens. Then it says make the electrons the same by finding the least common multiple. What's the least common multiple between 1 and 2? That's right, it's 2. So I have to make the electrons the same. That's 1 electron here, that's 2 electrons here. So I got to make both of these the same. So what am I going to do? I'm going to multiply this top half by 2 to make them the same. Okay? So now I'm going to multiply and bring down at the same time. So I have 2 times sodium with a +4. So that's going to give me 2 Ce +4. Okay? Plus 2 times 1 electron, that's 2 electrons. All right? I'm going to do the whole reaction side. Plus 10(2) yields. Then we're going to have sodium, 2 sodiums, because 2 times the 1 sodium. So that's going to be 2 Ce +3. Bring down your 10 with a +4. Plus 2 electrons. Now, you cancel out whatever's on the reactant side. If it's the same thing on the product side, you cancel out. You got 2 Ce +4s here, 2 Ce +3 here. That don't cancel. You got 2 electrons here. You got 2 electrons here. They cancel out. You got 110 with a +2 charge. 110 with a +4 charge. They're not going to cancel. Okay? So now you're going to simplify and bring down the reaction. So we have 2 Ce with a +4 charge plus Sn with a +2 charge yields 2 Ce with a +3 plus Sn with a +4. Now remember, I said this has to be balanced according to charge, right? So I have 2 sodium with a +4. So that's 2 times +4. So this right here is +8. I got 10 with a +2. This is +2. So this charge over here so far is 10. Okay? We got 2 times +3 here. That's going to give me 6. And over here we got 4. So this is equal to 10. So guys, we see that it is equal in charge. It's equal in charge and it's equal in ions. You got 2 Cs, 2 Cs. 1 Sn, 1 Sn. So it is equal in charge. Okay? So I'm getting ready to do another example, but that is going to be on another video.